So in this video we commence set 4 of linear modelling, and we're going to be taking our mathematical knowledge from the first 3 sets and we're going to be applying that knowledge to some real life situations and some real life contexts. The first thing we need to do is be able to form equations from sentences. So here we have a sentence: an electrician charges a call-out fee of $80 plus an hourly rate of $95 per hour. And from this equation has been written down. That's what we want to achieve, is to be able to read a sentence and write down an equation for that sentence. So first thing is to decide what are the variables. Okay, so an electrician's got a charge and there's an hourly rate. So what we deduce from this is that the variables are the charge, which of course is shown here, and the number of hours. So charge and number of hours. Okay. Now that's probably the trickiest part of this, is deciding what the variables are, because you can get mixed up. You know, you might think, oh well, is the variable actually like the hourly rate, because that's a different number for different numbers of hours, and you know, you can get a bit confused with these, but the main thing is just to practice and get experience with these. Okay, now we also need to be able to put the numbers in the correct spots. Here we've got a call-out fee of $80. Okay, now that is going to be fixed. That's not going to change. If the plumber comes out and works for 10 minutes or comes out and works for 10 hours, either way the call-out fee is $80. What does change is the pay that the electrician, or the charge that the electrician gets from working more hours. Okay, so for each additional hour, the electrician gets another $95. So we multiply the number of hours by 95, and that gives us the gradient. So the gradient is the one that can change, and the y-intercept is the one that's fixed. Okay, so gradient's the one that can change, but the y-intercept is the one that's fixed. So you can have a look at the next few and just get a feel for how they work, what type of variables are coming out of these, and where the numbers have got to go. So there's a good bit of practice there, but I'm going to go on to these ones here, which don't have equations yet, and I'm going to have a go at writing some of these equations down. Now you might want to pause the video at this stage and go through the process of deciding on the variables. What are the variables? Which one of these is the y-intercept, the one that's fixed, and also the gradient. These are really the 3 things we need to know before we write the equation down. Okay, so in this one, we've got Bree, and she can swim 25 metres at the moment, but each swim lesson she attends, she improves her distance by 10 metres. Okay, so what are the variables? Well, we've got the distance that Bree can swim, and I'll just call this D for distance, and we've got the number of lessons. And I'll give that the letter L for lessons. Now, what's fixed? What's the y-intercept? Well, at the moment, Bree can swim 25 metres. Okay, so that is the starting distance that Bree can swim. Now, this is tricky because, of course, her distance is going to improve, and so the distance she can swim each week will change. But her original swim distance, her starting amount, that's fixed, and that's going to be built upon. Okay, so that's going to be the y-intercept. That's the fixed value that won't change. Now, each lesson, Bree's distance improves by 10 metres, so that is our gradient, because every lesson, you multiply the number of lessons by 10, and that's the extra distance that Bree's been able to swim. Okay, so we need to get the variables the right way around. So of course we're going to put the dependent variable where the y variable is, and we're going to put the independent variable in the x variable position, or the spot where the x variable goes. So ask yourself, does distance depend on the number of lessons, or does the number of lessons depend on the distance? Well, distance depends on the number of lessons, so our equation will be d for distance equals 10 times L, the number of lessons, plus that 25. Okay, so that's our first equation. Okay, this one, we've got a charge and distance situation. So C for charge equals, okay, now it's 3.50, $3.50 multiplied by D for distance, or if you put it K for kilometres, that's fine as well. Either one would be okay, just as long as you define your variables, plus that flag fall of $8. So that's our equation for the taxi company. A cup of coffee starts out with a temperature of 85 degrees Celsius, but cools by 2.5 degrees each minute. So we've got our variables. We've got the temperature of the coffee, T for temperature, and we've got the time as well. So actually, we want T for temperature, and we could use, I'll do a capital T for temperature. Now every minute, well, you could use, say, M for minutes, or a little t for time is pretty common. Well, I'll use M for minutes this time, okay? So the temperature is going to be equal to, okay, that the starting amount was 85. We started out at 85. It's going to go down. So this time we're in negative for our gradient. Going to go down by 2.5 degrees each minute. So we multiply 2.5 by the number of minutes. Now, of course, because we've got a decrease in temperature, that is a negative 2.5 for the gradient there. Okay, a swimming pool is being filled from a garden hose. So we've got an initial depth of 80 centimetres, and every minute it increases by 2 centimetres. So we've got D for the depth of the swimming pool and M for the number of minutes. So our depth, being our dependent variable, is equal to 2 times the number of minutes plus 80. All right, so go ahead now and try the questions from the textbook that are in the description for the video.